Hey everyone, we're going to start 11.2 for Calculus 3. It's on vectors. Vectors are a great way for us to look at points in 3 dimensions and motion in 3 dimensions. Vectors are used in science to represent quantities that have both two things, a magnitude, which is the, well, I'll go over that in a second, and direction. Examples are force, velocity, magnetic field, things like that. Something that has both a heading and the magnitude is the strength or length of the vector. In textbooks, you'll often see it. Vectors are identified either in bold font or with arrows above them. The common way is with an arrow that has things like that. This is force, this is velocity, this is magnetic field. I tend to do it where I don't have the bottom of the arrow. The bottom of the arrow makes it easier to draw above the things without making it look awkward. You will also see me later on list vectors that have little carets above them. And when I do that, these all have a length or magnitude of 1. But we'll go over that in a little while. The vectors have an initial point and a terminal point. They got to start somewhere and they got to end somewhere. So here I've got point A and point B, and they do have a direction. So the line from A to B, I can either head from A to B or I can head from B to A. So I've illustrated that with the red AB and the blue BA. That magnitude is the length. It's a scalar. It's a real value. It's often referred to as the scalar of the vector, but it's also magnitude or norm, as we'll see in a little bit. And in textbooks, the vector part also appears italicized, or the magnitude, I'm sorry, appears italicized. So we put the vector has the arrow symbol over it. If there's a scalar on it, we'll see that in a little bit, how it affects it. It tends to be italicized in textbooks. When you have two vectors that are exactly opposite of each other, one is the negative of the other. Okay. If vectors are pointing in the same direction and have the same magnitude, they are considered equal vectors. They don't have to start at the same point. So I have V1, V2, V3. They are all going right 2 and up 1, right 2, up 1, right 2, up 1. These are all equal vectors. They do not need the same starting point. When we write them to distinguish them from points, we use the arrow brackets on them. Okay. So the arrows tell me it's a vector. They look like arrowheads, and vectors have a direction, they're arrows. In 2D, we write the same way we do points, X first, then Y. When we do 3 dimensions, we will do X, Y, Z. V4 has the opposite of V1, 2, and 3, if you'll notice. Instead of going right 2, up 1, it goes down, or left 2, down 1. We'll cover that in a bit. It's related to the negative that we were talking about a second ago. A vector that doesn't have magnitude and thus no direction is called the zero vector. It seems silly to make it up. Like, why talk about it if there's no magnitude nor direction? But it becomes important when we're looking at vector mathematics, arithmetic, and stuff like that. That negative of the vector we were talking about. So V4 is the negative vector for V1, V2, and V3. It points in the opposite direction, has the same magnet, but has the same magnitude. So negative V4. If we made V4 negative, it would point in the same direction. Let's put that up here. Let me do negative V4. V4 right here would be starting at the same point, but the opposite direction, goes right 2 and up 1. So that's negative V4. Okay. And that's it for this video.